So he came a little bit after that. So David Ricardo, his big contribution was comparative advantage. So we learned last time that Tom had an absolute advantage in production, but that didn't matter in terms of the benefits that each party could enjoy by producing, specializing in the thing in which they had a comparative advantage in, and trading for it. Okay, so today I want to do a little bit different application of comparative advantage. We're going to start with our schedule goggles and look at the production possibilities curve. Whoops, I need to write that out for the first time. The production possibilities curve, the PPC. It's also referred to sometimes as the frontier, the production possibilities frontier, same thing. And this is an economic model that shows the maximum combination, shows the maximum combination of two goods an economy can produce given its available resources and technology. Shows the maximum combination of two goods an economy can produce given its available resources and technology. All right, so I think it's easiest to just jump into an example. Suppose that an economy can produce two goods. Suppose an economy can produce two goods. Beer and pizza. And I'm going to have you put your schedule goggles on and look at the quantity of beer and quantity of pizza that this economy can produce. And so it's possible that it can produce 20 beers. But if it does, it can't have any pizza. All resources are being devoted towards beer production at that point. Another possible combination is 19 beers and 1 pizza. Another combination is 16 and 2. Another combination is 12 and 3. Another combination is 7 and 4. And finally, the economy can have 5 pizzas, but it would mean no beer. So I want you to pull out your graphing goggles and graph out these points that we identified. So put pizza on the horizontal axis, beer on the vertical, and for this problem I want you to be a little careful with your graph. Sometimes we get sloppy, but since this is one of our first ones, I want you to be kind of careful with it. And so what I mean by being careful is I want you to evenly space the numbers because we need to see something pop out of this. So on the horizontal axis, I've got a P for pizza, and I want you to just kind of evenly space 1, 2, 3, 4, 5. And then on the beer axis, we're going to do the same thing, but you don't want to use that big a spacing most likely, depending on how much paper you're using. But just kind of go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and finally 20. Just kind of picked off the points that we had over there, but I evenly spaced my little dashed marks. All right, now plot those points. Now, if you were careful with your plotting, what does the shape of your dots look like? Kind of bowed outward, right? So it should be kind of bowed outward if you were really careful with your graph. All right, so what I want to think about now is the cost of things. So what would you say the opportunity cost is of the first pizza? So write this expression down. The opportunity cost of the first pizza is, what would you say the cost of the first pizza is? Yeah, 1 beer, good. 1 beer. The opportunity cost of the second pizza is what? 1 beer? 4 beers? 4? 4? High school beer? 4? I hear a 3. So I got a 3 and a 4. Why do you say 3?
Well, you said the second pizza, which I assume you meant after the first.
Oh, okay. So second after the first. Why'd you say 4? All right. So Abby's right here on the language. The second is how many pizzas? 1. The second pizza. Now, had I asked, what is the cost, what is the opportunity cost of the first 2 pizzas? Answer would be, Michael? 4, good, right? So the first 2, if we were incrementally jumping from here to here, is 4. But the second pizza is actually just 3. All right, let's make sure we're all on the same page. Third pizza, 4. All right, so if we jump over here, look at what we're doing. Let's just change interpretations a little bit. We're going from 0 to 1. It's the first pizza, so we're losing 1 beer. The second pizza is still 1, but this time it's costing 3. We're gaining 1 by the third, but we're losing 4 beers. Opportunity cost of the fourth? 5. And then finally the fifth is 7. So I want you to write this all out because it's going to hopefully help here once we get down to the next level of this. So finally the fifth is 7. So what costs more, the 7th or I'm sorry, the 5th pizza or the 1st pizza? Which one's more costly? The 5th. Well, wait a second. When I go to Pizza Time and I order a medium pizza, it costs $11.55. And if I order a second one, if there's not some special deal running, it also costs me, where's is that Katie on the cost? It costs me $11.55. In fact, each pizza costs me $11.55. But this is saying that the costs change. And they change in an increasing way. My cost of additional pizzas are going up. So why? Does this one have more pepperoni and extra cheese? Nope, I'm not allowing that. So they're identical pizzas. Now, granted, I made up these numbers, but there's some economic reasoning underneath this. So why is opportunity cost increasing at the margin? This would be a great test question. So for now, it's your homework question for next class. Why is opportunity cost increasing at the margin? On a separate piece of paper, I'll have you turn this in next time. Bring back the answer to that. We'll see you on Friday.